Hello everyone, today we will discuss some more problems on degree of freedom. The first problem is the three particles are connected by light rigid rod to each other. If system is moving in three-dimensional and two-dimensional space, then what is its degree of freedom? Now your problem is like that there are three particles. This, let us say this is mass m1, this is mass m2, and this is mass m3. Say the distance between mass m1 and m2 is L1. Distance between mass m2 and m3 is L2. Distance between m1 and m3 is say L3. Here the distances are fixed, they are not going to be changes. L1 is fixed, L2 is fixed, and L3 is fixed. So here the degree of freedom, you know that the formula is it is like nd minus k. Here n is number of particles, d is space, and k represent the restriction. So here the number of the particles are 3, and we are considering first the three-dimensional space, so d will be 3. Now the restriction is that the distance between the particles m1, m2, m3 is fixed, so the restrictions are here 3, so degree of freedom will be 6. If the similar type of system and it is moving in two-dimensional space, then the degree of freedom will be, here the number of particles are 3, we are considering a two-dimensional space, the restrictions are 3 again, so here degree of freedom will be 3. The next problem is problem number 2. The 10 particles are connected to each other by light rods and system is moving in three-dimensional space, two-dimensional space, and one-dimensional space. Then calculate degree of freedom. You must remember that if the number of particles is greater than or equal to 3, then it can be considered as a rigid system. So for a rigid system, the formula for degree of freedom, you have to note this, that degree of freedom will be represented like d plus 1 upon 2. Here d represents the dimension. For three-dimensional space, here for three-dimensional space d will be 3, so degree of freedom will be 3 plus 1 by 2, so it will be 6. For two-dimensional, you know that d will be 2, so degree of freedom will be 2 plus 1 divided by 2, so it will be 3. For one-dimensional, you know that d is 1, so degree of freedom will be 1 plus 1 divided by 2, so it comes out to be 1. Now let us take the other example. Suppose a system is having the number of particles are 4 and the distance between the particles is constant. Then what will be its degree of freedom? You can see that suppose there are 4 particles and the distance between the 4 particles is constant. Say this is m1 particle, this is m2 particle, this is m3 particle, this is m4 particle. The distance between m1 and m2, it is fixed. The distance between m2 and m3 is also fixed. The distance between m3 and m4 is also fixed, and distance between m1 and m4 is also fixed. If these distances are fixed, then you also know that distance between m1 and m3 will be fixed, and distance between m2 and m4 will also be fixed. So here the number of particles are 4. Now what will be the number of the restrictions here in this case? If you see here, the restrictions will be this is 1 constant, this is number 2, this is 3, this is 4, this is 5, and this is 6. So here 6 constants, so k we can put 6. So if we use the degree of freedom, our earlier formula, that was equal to nd minus k, then it comes out to be n is here number of particles are 4, and the system is this system is moving in 3-dimensional space, so here d will be 3 and k is 6, so here degree of freedom will be 6. Now if we consider the other example, suppose there are number of particles are 5, then what will be the degree of freedom in this case? It is very important to understand that suppose there are 5 particles and the distance between the particles is again constant. Say this is m1 mass, this is m2 mass, this is m3 mass, this is m4 mass, and this is m5 mass. The distance between m1 and m2 is fixed. Distance between m2 and m3 is also fixed. For a rigid body, all these distances will be fixed, right? Now we can draw a line from m5 to m2. If all these m1, m2, m3, m4, m5 are fixed, then this distance will also be fixed. Again we draw a line from m5 to m3, and I draw a line from m1 to m4, and I also draw a line from m1 to m3, and I can also draw a line from m2 to m4. So here you see if you count these distances, then you will find that your k here is 10. So in this case, when the number of particles is 5 and the distance between the particles is constant, or you can consider it as a rigid body, then your degree of freedom will be, your number of particles are 5, your system is moving in 3-dimensional space, so d will be 3 and the restriction is 10. So the degree of freedom here will be 5, but it is not true. You know that for a rigid body, if the number of particles is equal to 3 or greater than 3, then always degree of freedom is 6. Right? So here what we can explain, here the restrictions are 10. Here we will say that one coordinate is the superfluous coordinate or redundant coordinate. How you can define the redundant coordinates or superfluous coordinates? Suppose a particle is thrown vertically along the y direction. This is your y direction and this is your, say, x-axis, and this is your z-axis. This is the origin, and the particle is thrown, along the y direction. Suppose its initial velocity is uy, and after some time it travels a distance y in upward direction. Then you know that its equation will be, it will be like y is equal to uy t minus half gt square. Right? This is your actual equation for this motion, but you can write your here x is equal to 0 and z equal to 0. So here x equal to 0 and z equal to 0, these two coordinates are the redundant coordinate. If you have to specify the motion of the above system, then your relevant equation is y equal to uyt minus half gt square. Your x equal to 0, z equal to 0, these are non-relevant coordinates or values, so these are called as the redundant coordinates or superfluous coordinates. So in this case also there is one redundant coordinate. So here actually the degree of freedom is not 5, the degree of freedom is here 6. Right? So you have to always remember that if the number of particles are equal to 3 or greater than 3, then it will be considered as a rigid body system, and the degree of freedom for these cases will be explained by the formula. Always remember d plus 1 by 2. Right? Thank you.